Hi! Have you asked yourself the following questions several times? How can you install SeisComP in 5 minutes? It's easy, so let's get started. All the following steps we will proceed in the new release of SeisComP 7. Although later versions may differ in details, they will work similar. Visit our website gempaGmbH and click the large SeisComP button. You will find more information about the requirements and all the prompts used in this video, as well as additional links on the topic of SeisComP installation. Okay, first we need a console. Change into the home directory. Use wget to download the gempaGmbH software manager, GSM. Then, extract the archive. We don't need the archive anymore, and delete it. Next, we run the GSM setup to initialize the software manager. Confirm the SeisComP version 7 and the options regarding your system. If you don't have access to a private repository, simply say no. You can confirm the defaults for the next questions about directories and settings by pressing enter. Perfect! Now we need to run a GSM update with this new setup. Alright, now we install SeisComP and the default map package. This can take a little longer, even if it's the minimal map, but for the whole world. Dun, diddy dun, dun. Confirm that you want to continue. Now, we will install the minimum required dependencies to get started with SeisComP. Of course you want to continue. Start MariaDB, and we are done with the installation process. SeConfig will help us with the first configuration steps. When you first start SeConfig, the wizard automatically starts to guide you through the initial setup. Click Next. Enter your organization's identifiers. All of the other settings are fine for the initial setup. Just confirm the defaults. Click Finish. You will then be asked for your password. Pass the authentication. Setup successful. Hit the close button and we're all done with the wizard. Let's switch to the inventory panel to import station metadata. We will use the built-in import from FDSN Web Services function. The default parameters will download the geophone network, GE, from the FDSN web service run by the GFZ. As 20 SPS data are enough for this demonstration, we only request BH channels. Click Fetch to see all available stations and channels for these parameters. Clicking OK will download the XML file, convert it to SeisCompML, and place it in the inventory directory. Click the Sync Keys button to create the station key files required to bind our stations to modules in the next step. That was easy, wasn't it? Switch to bindings. The upper left panel lists all networks and stations in a tree-like structure. In our example, it's the imported GE network. Let's first define which are the preferred channels we want to process and visualize by default. As we only have downloaded BH channels, we will bind those to each of your stations. Add a binding profile to the global module on the right and name it BH. Open it by double-clicking it. You can edit the binding profile parameters in the center panel. Set DetectLock ID without assigning a value and type BH into the detect stream parameter. Then, drag and drop the profile icon from the lower right panel onto the GE network. The binding profile will then be applied to all stations in the network. There are 6 stations which use non-empty location codes. Assigning the current BH profile to them will result in issues later on. This can happen, and how to resolve it could be part of another demonstration. We accept this circumstance during the course of this demonstration. We still won't receive any waveform data for our stations to process. In order to do that, create a seedlink binding profile. Select the seedlink module and add a profile named geophone. Double-click to open it. Add a new source instance with the type chain. No name is needed here. Expand the new chain entry, then enter geophone.gfz.de for the address and bh?d for the selected to stream only BH channels. Drag and drop the geofon profile onto the network, then save all changes. For the final configuration step, go to System. Click Update Config. SC Master module will start, and all your configuration will be synchronized with the database. Look for SeedLink in the module table. Select it and start it as well. Data should now be flowing right into our system. You can close SeisComP. It's time to start SCRT-TV, the real-time trace view. By default, it displays the last 30 minutes of our configured vertical channels from the global bindings in real time. It is a very versatile tool for data visualization and even preliminary event location. We are starting it right now to check that our SeedLink server is configured correctly. Great, our data is flowing! As second tool, we will look at scconfig, the map view. It shows all of our inventory stations as markers on a map, allowing us to check their configuration, the current ground motion, and the data latency. As previously mentioned, the 6 stations with non-empty location codes are tagged with a warning symbol. All colored symbols represent a certain peak ground velocity measured from the data we are receiving. We are not yet received data for stations with black symbols. Troubleshooting this issue could be part of another demonstration. So, 5 minutes later and we have installed, set up and started a very basic SeisComP system. From this point on, there is a lot to upgrade, automate, extend and tweak with various open and commercial SeisComP tools. Hope you enjoy this quick session. See you!